All right, and thank you everybody for joining the webinar. Welcome to the webinar for innovative apoptosis analysis in 5 minutes. We're going to be discussing image-based solutions. Today we're going to have Henrik Thompson on the line from Chemometec, myself Sean Burke from Novo Software. We're going to talk about some interesting apoptosis assays that use the combination of some instrumentation from Chemometec along with third-party data analysis by Novo Software. So you can really get into that data. You can move from any of your data displays in FCS Express down to individual images, and Chemometec provides a very unique way of acquiring that data. Just as a little background, Chemometec and Novo Software have collaborated to enable data import from the NucleoCounter NC3000 image cytometer. This is for advanced cellular assays. And FCS Express image cytometry can also import data from the NucleoView NC3000 software, from the FlexiSite Advanced Analysis module. And our companies are working together to develop these capabilities further, and we also provide many layouts specific for Chemometec applications. But Henrik Thompson is going to join us on the line now to give us a much greater overview of what Chemometec can do and what they have been doing with some new apoptosis analysis solutions. So Henrik, are you on the line?
Yes, Sean, thank you very much for this very nice presentation. And I'll be sharing my screen right now, so everybody should be able to see it. I will introduce you to two instruments from the Chemometec platform. Then I will discuss give you a short introduction to the vitality assay, which is this very special assay invented and patented by Chemometec, where we can actually measure apoptosis in less than 5 minutes directly on cell samples without any washing or any other steps than just adding the dye to measure the sample. I'm going to show you some data in the end and how to export these data into the Novo software. And then I'll hand this presentation back to Sean, and he will show you how to work further on with all the data in the Novo software, the FCS Express. So first I want to introduce a very new instrument coming out from us. This is a NucleoCounter NC250. It's a cell counter, it's a viability measure, and it can measure the cell health, it's the apoptotic measurement, and then finally it can do a very, very rapid and very precise cell cycle profiling. So if we go on, so we have an instrument that is objective. There is no focusing. There is no need for other things. Just load your sample, press run. We get high-speed cell counting on this instrument, as we do on all of our instruments. In this case here, we have 8 samples done in less than 3 minutes. So we do the counting and we do the analytical assays of the cell health determination. This is what we're going to discuss later and what this webinar is all about. And we have the cell cycle profiling, all on a low running cost, and there is no calibration, maintenance, service, or anything. So once you have it, just run it, and you just keep going with it. So the predefined assay in this one, just press run, get the one-step viability cell count. That covers 95% of all cell lines, including most of the primary cells you work with, the mammalian cells. And then we have a two-step viability cell count option for aggregated cells and cells grown out in microcarriers. Normally we say this is the assay to go to when other cell counters have given up. So we can actually very quickly, very easily count cells. And finally we have the two-step cell cycle and the cell vitality. It's not necessarily enough to know if your cells are alive or dead, but how healthy are your cells before they die. Can you tell that they're dying in a couple of days? So that was the 250, but the main instrument for today would be the NC3000. The NC3000 can do all what the NC250 can, plus a lot more. So we have have in the NT3000 7 LEDs and done different emission filters covering the range from ultraviolet to far red. You are able to create your own protocols using the FlexiSite module, and by that you can actually create protocols to look for different markers. We've seen different CD markers being used, and the mitochondrial tracker, and so on. And on top of that, we have a range of fixed protocols, so different apoptotic protocols, cell cycle protocols, GFP, transfection efficiency protocols, and so on. And to run it all off, this is also a cell counter, high-speed cell counting, the same as the NC250, where you can count your cells directly on slides or in cassettes, which is it's easy to operate. There's no training calibrating, and there's no flow in this instrument. It's based on images, so therefore we have no clocking, no rinsing, so no maintenance. We can export the data to FCS Express, and we'll do that later, and we can also visually inspect the cells, and all this for low running cost. The fixed protocols that we have already in the instrument, on top of all the protocols you make yourself, is the viability and cell count, the cell vitality, which is the topic of today. We can go and look at mitochondrial potential using the JC1 dye. We can look at annexin 5 binding to the cell when the phosphatide serine is presented on the surface of the cells. We can look at caspase activity with the flicker assays, DNA fragmentation, do cell cycling on it, and look for GFP transfection efficiency. If we go into the FlexiSite option of this instrument, we have the possibility to use 4 of the 5 available LEDs. It's the UV LED, violet, blue, green, and red LEDs, combined with a range of different emission filters. In that way, we can ensure that you can see whatever fluorophore that fits into any of these combinations of light source and filter. So the workflow on an NT3000 is quite easy. You prepare your cell sample, you turn on your PC and your instrument, and finally you put in your sample, press run, get the results displayed directly on the computer. No calibration, no maintenance, no whatever. It's very, very easy. So use your time to analyze your data rather than acquire the data. So today's topic is apoptosis. There's different ways to look at apoptosis. There is the phosphatide serine externalization, annexin 5 assay. You can look at caspase activity, collapsing of mitochondrial potential, DNA fragmentation in different way. You can look at microscopes and see membrane leavings and so on. But quite recently, there's been more and more publication coming out on the redox potential, and that a drop in redox potential in cells actually can be used as a apoptotic marker. So the redox potential of the cell. In the cells there is like 3 redox couples. There's the NADP, NADPH, there's the GSSG, GSH, and then finally there's the GRX. So we have the NADP and the thyroidoxine, which are the 2, you can say, minor sources of redox buffering in the cells, whereas the glutathione, the GSH, is the high source of the main source of redox potential in the cells, mainly because you got a higher concentration of the GSH in the cell. So this is the principal redox buffer of the cell. The GSH is located mainly in the cytoplasm, and it's mainly in the form of GSH, the reduced form, whereas in the oxidized form, GSSG is more located in the different organelles in order to make, oh, it's a word missing here. sulfide bindings possible. If we go on to look at what happens in proliferating cells in terms of the reduction potential of the GSSG, which is the oxidized version of the GSH, how do that correlate with the biological status of the cells? In cells with highly proliferating, they will have a high potential in them. Whereas if you move toward growth arrest or even apoptosis, the redox potential of the cell will drop. And this is then used by us in order to detect apoptosis. We do measure the intracellular amount of GSH, mainly GSH, also other diols will be measured by the VB48 dye, our vitrobrite dye. The VB48 is a non-fluorescent molecule, but when it's bound to reduced thiols, reduced glutathione here, it becomes fluorescent. And we have shown that it is highly fluorescent bound to GSH, whereas alone it's very little fluorescent, and GSH and GSSG and water is non-fluorescent at all in our system. So therefore we can show that the GSH VB48 combination gives a good fluorescent signal that we can use onwards. There's other ways to measure the amount of GSH in cells as MCB assays, the monochlorophylline assays. However, they are very time dependent. So whether you measure your cells after 5 minutes, after 10 minutes, after 15 minutes, you get different fluorescent intensities. Where in the VB48, that is our proprietary dye, there's little to no difference whether you measure immediately or you let it stand for a couple of minutes. So therefore, it's much easier. You don't have the hassle with going through the measurement of the timing too. And yeah, I've just got a question here. I'm following on the questions so that that we can have the questions whenever the slides are appropriate for them. Yeah, it is, as far as we know, it looks like this is the SH group of the GSH that the VB48 binds to. Thank you for the question, and just write in questions in the question box along the way, and I will try to answer them during this presentation. If we look at a study done by Mette Skinnersø, a former employee at Chemometec, she looked at the correlation between the VB48 and other known apoptotic markers, antigen 5 and caspase 3/7. And in this case here, we have marked in the left side, we have control and camptothecin treated cells, where you see very clearly that you have some high intense VB48 cells with the arrow pointed, and in the same time they do not present phosphatidylserine on the surface and don't bind the antigen 5. Where if you have a low signal of VB48, the cells will be apoptotic and binding the antigen 5 to the cell membrane. So it's a good marker here to see that, yeah, apoptotic cells are less VB48 intensive than non-apoptotic cells. And the same shows with the caspase correlation, where we see the high intense VB48 cells being not stained by the caspase flicker dye here, where the low VB48 stained cells will be positive for the caspase flicker stains. And if we continue to the presentation done on the paper, the paper made by Mette and more people, is look into the surrogate and V-high cells and treat them with either camptothecin or TNF-alpha. And what you see during treatment is that on the y-axis we have the annexin 5. So you see during after a certain time of treatment, you see cells go into apoptosis. In the same time, you will over time here, especially in the 15-hour on the Jurkat, campesine-treated Jurkat cells, you will see that they also tend to shift towards a lower white bright intensity. So this shows that the white bright is a slightly later marker than the annexin 5, and the same is shown on the V-high with the TNF-alpha treatment. That I'm sorry, that the cells will be first measured as apoptotic from the annexin 5 dye, and then afterwards kind of drift down in V-bright 48 intensity. So again, if we look into the caspase 3/7, identical to what we saw in an annexin 5 assay, we see here that first we get an apoptosis measured by the annexin 5, sorry, the caspase in this case here, and then later on it drifts down in V-bright 48 intensity, and that way we can actually see that caspase 3/7 activity is slightly earlier than the white 40 apoptosis. So the conclusion here is that white 48 can be used to measure the cellular thiol level, and the reduced level of free thiol, giving a low stain of VB48, correlates with either phosphatidylserine externalization or caspase 3/7 activity. So we actually know now that this correlates with other apoptotic measurements, so we say this is an apoptotic measurement, however slightly later than the annexin 5 and caspase assays. Measurement of the GFH could then be included into a repertoire of apoptosis assays, mainly because it's very fast and easy. It's simply just mix a dye to your sample, measure. Finally, for this data, we would like to acknowledge Mette Skinnersø and Mikkel Rode, Søren Kjærulf. They've done a very good job, and you can read more of their on the paper on a novel and rapid apoptotic assay based on thiol redox status in the cytometry A. I would now go further into the software. So our NT3000 software will look like this when you open it and have an instrument connected. So we can acquire images in the software just by selecting the assay and then press run, get the image, and there is no hassle like calibrating or anything like that. I will now show you how data will pop up. Whenever you do a run of an assay, you will have data popping up in our plot manager showing the intensities of the dyes used. In this case, the vitality assay measured on the NT3000, we use 3 different dyes. We use the aquinine orange as a counter stain to localize all the cells. We use the VB48 to measure the cell health or the apoptosis of the health, and we use rubidium iodide to measure live and dead cells. I would like to also include in this plot manager a measurement of treated cells like these. So now we have 2 measurements, one untreated, one treated. Basically, you can see that there is a shift in the middle plot. See, you have in the middle plot you have a main population in the negative sample of live healthy cells. However, in the treated cells, you start to see rubidium iodide stained cells, the non-viable cells. And in the same time, you will see that there is a drift of cells going to lower health state or into further analyze this, we can actually put in different quadrants and markers. So in this case, I put in a quadrant very close to our healthy population. I take down the upper leg in order to have the population of non-viable in the top. Lower right would be our viable healthy cells. Lower left would be our apoptotic cells. I just got a question on how samples are treated with the VB48. It's on our system we have different solutions for staining the cells, and for this vitality assay we use the solution 5, which contains the microbride, the acridine orange, and potassium iodide, and it's simply mixed directly with your cell sample in media and PBS in 1 amount of dye to 19 amounts of sample, and then afterwards load into one of our Chemometec slides, put into the instrument, measure it. So very easy, no washing and other steps. So it just makes the dye with sample, put it in the slide, measure. And no setting up of light sources, anything. This is an already fixed assay, so everything's pre-done. So it's really just a matter of measuring the data. If we now compare this negative sample to the treated sample, just by typing in the row number, I can apply the same dating. And it's very easily here to see that not only do we have a shift towards more dead cells, we also see a huge shift towards the lower level of VB48. I have a sample of already pre-analyzed data that I would like to show you. Just remove these two here and open the webinar sample here. So we've done several samples in 3 different times. So we have a T time 1, time 2, time 3 of several different treatment on cells. And in this case here, I showed the negative. This is our control. You see the name of the samples out here. This is called negative. This is our control. Then we have N-minus line. We have camptothecin. We have NucleoCounter, and so on. It is easily seen here that after some hours of treatment, that there is a shift in some of the samples. However, the shift are not that profound. You see it going from 4 and staying on 4%, and for the NucleoCounter, it's slightly moving in. It's a non-significant shift, you could say. In the third column here, we're then measuring the intensity gated to only show the viable cells. So this is the intensity, VB48 intensity of the viable cells. And on our untreated, we have 96% healthy live cells. And it continues on the next one to be around the same. 93% of our NucleoCounter treated cells is not really a shift, going from 4% apoptotic cells to 7%. However, if we, instead of looking at the combined intensity for the cell, we then look at the most intense spot in the cell, we will see here that again we have these 95, 96% of cells being healthy and 5% apoptotic cells, shifting slightly to 6, 7% on some of the treatments. But on the NucleoCounter, you see suddenly it dropped down to 20% being apoptotic in a way where the cell itself hasn't lost its overall intensity. It's not drifted really, but the location of the intensity shifted from somewhere at a single spot in the cell to a more spread out location in the cell. So actually we've seen that by looking at this factor, we can see the apoptosis even clearer. This is something only done by image cytometers, where you actually do take images of the cells and measure the exact dyes, or to some extent the location of the dyes. So we can actually see here that when the cells are healthy, the dye are more concentrated. However, when the cells start to go into apoptosis, the dye concentration spreads out, but still internal of the cell, since there's no drop of overall intensity for the cell. If we move on, I'll just erase the drawing, sorry. So if we move on down to other time tables, you will suddenly, if we go down to T3, you will see that now the nucleosol treated sample here has a higher level of apoptosis and still also spreading out of the dye internal of the cell, and it's even more. If we go down to the last one here, it's very clear that we have a relatively high level of apoptotic cells, and here the dye is really spread out into the cells. However, the cells really also dying off. So based on this, we can actually say that this assay, where you measure the apoptosis, is fast. It's like, and I have a question, what is NucleoCounter? Is an apoptotic inducing reagent. It's NucleoCounter, N-O-C-O-D-A-C-O-L-E. But we can use this instrumentation to measure the apoptosis in an easy, fast way without having to calibrate or setting up a lot of parameters. Just erase the drawings here again. So how do we then move these data into the FCS Express software? Actually, by clicking on the file browser, I get up a file browser for the NC3000. I can make it slightly bigger so I can see all the files. I can simply just mark all the files, right-click, and batch export these data. And I can here choose which of the parameters I would like to export. I would like to export the PI area, the intensity, and the max intensity. The same goes for the accuracy in orange and for the UB48. So in that way, we can export our data into an ACS file format that are readable by the FCS Express. Just got another question on whether, Just got a question on if you can use the UB48 and other cell types, that non-mammalian cell types. And we have seen that there might be a possibility for using these dyes on yeast and maybe even on bacteria, but that's not something we have a final proof of. So I would be rather a little not too forward moving on using it on other cells and mammalian cells. So when you export the data, you can actually import them into the FCS Express, and then I will hand these data over to Sean, and he will then now show how to analyze these data in the FCS Express. Finally, if you would like to test this instrument and this dye on your cells, you're very welcome to go into the Chemometec webpage and apply for a free trial. We're very happy to come visit you, either ourselves or one of our partners, and set up an instrument and show you how it works and let you have it for trial for a couple of weeks. So please go to our website page and then look into a free trial of this instrumentation and this assay, along with all the other assays that are usable from the NC3000 and NC250. So, Sean, I would hand over this presentation to you now so that you can use the data that we just exported from our software in the FCS Express.
Hi, Henrik. Thank you very much for that presentation. I just wanted to follow up with a few questions that had come in during the section as well. And one of those was, besides the NucleoCounter slides, can other slides be used for detection? Things like chamber slides, can that be done?
No, you can only use the NucleoCounter slides for the NucleoCounter instruments, and that is because we do have automatic focus in them in our instruments, and we need the NucleoCounter slides in order to work with these automated focuses. So that's why we have only the NucleoCounter slides available for the instruments. However, they come both in an 8-chamber and a 2-chamber slide. The 8-chamber measuring 10 microliter with the 2-chamber measuring 30 microliter sample.
Great. And how long does it take to run a slide on the NC3000?
I would say for the Vitabright assay here, it would be less than 5 minutes. So mixing of the dyes to the sample, loading the sample into the dyes, putting the slide into the instrument, waiting, get your result is less than 5 minutes in total for 2 samples and an A2 slide.
Great, fantastic. All right, so with that being said, if there's any other questions for Henrik, feel free to ask them as we continue along with some more of the data analysis section here. Also, if you have any questions for myself, Sean Burke from Novo Software, as we're going ahead, feel free to stop and ask them. We'll try and address them as we go, or we'll come back to them at the end. So as Henrik mentioned, that the Chemometec instruments can export from their software in a format that FCS Express can read. And just so you know, I want to give you a little background about FCS Express. It has been developed over the last 15 years as a powerful flow cytometry data analysis and presentation software. So it's just been in the last 2 to 3 years that we released our image cytometry product, and that companies like Chemometec with their instruments have come on board to export that data directly to us. And this is because the main principles of flow cytometry and image cytometry overlap. Things like taking multi-channel fluorescence data, plotting that data in scatter plots and histograms, so we can look for statistically significant differences and changes. And the added power that you get with FCS Express image cytometry is that we can take that image cytometry data a step further by leveraging all of the analytical tools that we have in our flow cytometry toolbox that has been developed over a decade, and we can allow you to analyze these multi-parametric data sets while relating the results back to the original images. So you don't just have dots on your screen or bins in your histogram. The whole idea behind image cytometry and what Chemometec is doing is that they're taking these beautiful images, and there's lots of information associated with these images. So as you're going to see as we go through the data analysis today, you're going to not just lose the ability to look at those images, you're going to be able to relate any of the dots, any of the gates that you see back to the images, move from population-based analysis down to single cell and single image analysis for those. So I wanted to start again just by describing the basic workflow here again. When you're working with image cytometry data in FCS Express, there has to be some sort of image acquisition and image segmentation done, as well as feature extraction. This is all done seamlessly by the Chemometec NucleoCounter and FlexiSight software. And what you can do is export that data, as Henrik showed you, in the form of a .acs file. That is a file type that FCS Express image cytometry can read, as well as any of the FCS file exports. And then you can bring that data into FCS Express for further data analysis, for report generation, and for communication and publication of those results. So for those of you that aren't familiar with FCS Express, if you haven't seen it before, we're actually in FCS Express right now. One of the things about FCS Express is that it looks and feels just like PowerPoint. So I'm going to show you a little bit about that, and then we're going to jump right into the data. But essentially, when you create a layout in FCS Express, you end up with this blank piece of paper. This looks just like a PowerPoint slide. Anything that you put on this paper can be analyzed. It can be exported directly to PowerPoint, which you're going to see. It can be exported directly to PDFs, to Word documents, any Microsoft Office instruments. So let's actually open up a layout. Let's open up where Henrik left off in the NucleoCounter software. And you can see here that we're actually in FCS Express now. We've inserted what we call dot plots here, or color dot plots. And the color dot plots in FCS Express are showing dots as the colors of the gates that they fall within other parameters. So in FCS Express, you can create gates in the software by using this gating tool here. You notice if we just select a gate and we draw that gate onto a plot, you can create a gate. And as we move that gate around, the cells that fall within that gate will highlight, our statistics will update. And it's also added to what we call the gate view on the left. And this is showing any of the hierarchy of gates that we've set up. So just like in flow cytometry data where you can set up hierarchical gates and look at children and parent populations, we can set all that up in FCS Express as well. We also have unlimited undo, so I'm going to undo that gate addition and move so we can actually remove that gate. But what you can see is we've recreated the analysis that was done in the FlexiSite software. We have our apoptotic population as being PI negative, VB48 negative. We also have our viable cells as being propydian iodide negative, but VB48 positive, and all of our non-viable cells up here in the top as being varying degrees of VB48 positive, varying degrees of VB8 intensity. Mostly these are going to be negative, but you also have high propydian iodide in here. And again, you can see that these gates apply for our three different replicates here, or I'm sorry, our three different time points. So in the assay that Henrik had put together, for each of the individual treatments, there was 3 time points: time point 1, time point 2, and time point 3. What we're looking at here is the negative control for these time points. Now, when we work in FCS Express, we work through something called the data list, and the data list has all of our different controls and all of our different experimental samples that we have in here. You can see that we've loaded up 4 of the treatments: the negative control, the MIMO, CPT, and ETO treated samples. And what we can do is actually view all these side by side in the layout, and through using what we call the next and previous buttons, we can easily skip between the samples and compare these all side by side. And you're going to see this come into play when we work through this data a little bit more. Now you're also going to notice on the right hand side we have these images, and in these images these are called picture plots in FCS Express, and to insert one of these we just come up to the insert tab, we choose picture plot, and we create that picture plot. And again, that's what we've done over here on the right hand side with the backgrounds colored as black. And in these picture plots, there's actually many different channels. We have our all cells, which is our acridine orange staining. We have our viable cells, which is our VB48 staining, and our non-viable cells, which is our propydian iodide staining. And as we change these channels around, we can easily come in and review what is going on in these different channels. Now, the nice thing about a picture plot is it isn't just a static image. We can link any of the cells in these picture plots back to the individual dots on the scatter plots, any of the scatter plots or any histograms that we create. So if you watch as we adjust this VB48 cells gate, and we choose to add or remove cells to that gate, the cells that are being backgated on this image, or the cells that were once green, are now changing color because they no longer fall within that gate. And this is very useful because we can see that just when we set up these gates, if we want to find out where all the viable cells are on this particular image, we can apply this gate by dragging and dropping it directly onto the picture plot. And what you may have noticed is that all of our non-viable cells that were in red have now disappeared. So now we're only looking at the viable cells as determined by VB48 staining. Now, again, a useful thing is if we want to look at non-viable cells in these populations or in these images, we can drag that non-viable cells gate here, and then we can actually see in our image what is going on and where those non-viable cells are. Do they group together? Or, if we want to actually come in here and magnify this, we can see what those cells look like. Are they blebby? So, we're getting all of the important image information that we painstakingly acquired and being able to have access to that. And again, if we want to go and look at our apoptotic cells, we can see that in this particular negative control, there's only a few of them, and there they are. It's actually only 1.29%. Now, this also works the other way in FCS Express. So what if you had a particular field on your image that you were interested in looking at? Maybe you thought that this particular section of your image was interesting to look at. And we'll set up a gate on that picture plot, and we'll call these interesting cells, and we will color these orange. You can see that in this interesting cells gate, we're showing that these cells represent 7.71% of the entire population found on this slide. Again, as we move this gate around, we can see those numbers change. But the important thing is if I drag this gate over onto our dot plot on the left, we're now analyzing only the events that fall within this particular region of the image. So for whatever reason, if there's some sort of artifact, if your cells have clumped together and you didn't get good segmentation, for whatever reason, you can apply one of these gates to remove any artifacts, any cells that you don't want to analyze. You can zoom into a certain population and get more information about that. So again, that's by creating gates on our image and then applying that directly back to the dot plot. And let's actually undo some of these changes here. We'll remove this gate. And I'm going to show you the last way that we can actually get down to a single cell analysis. We actually just had a question that came in that says, can we detect VB48 or other probes in single cells on the screen? And absolutely, you can see here that on any of these plots we have lots of different parameters that we can choose from. In this case, there was 3 different fluorescent intensity parameters. There's a max intensity and the intensity for each and an area for each. So what we can do is if we want to look at, say, let's look at the VB48 positive cells. And we'll apply this gate over here to this plot on the left. What we're actually looking at now is acridine R intensity versus propydian iodide. So since these cells are all positive for VB48, that means when we set a new gate here, we're actually looking at triple positive cells. These are cells that are positive for VB48, positive for acridine orange, and positive for propydian iodide. So we can detect many different probes in the same cell, and since we have set this gate up now, and we're looking at these triple positive cells, if we apply that gate back onto the image, we can find out where these triple positive cells exist. And you can see here that because we've colored these in purple, we zoom in on these, we can see that these are the cells that we've just chosen. So this is something that we're very used to doing in flow cytometry by taking or by setting up gates and setting up hierarchical gates on many different probes and parameters. We can interrogate different phenotypes for our analysis, and you can always go back and figure out where these cells came from. Now that we have the image cytometry version, you can go back to the actual images. Now, the last kind of analysis that we have, the last kind of bread and butter of working with image cytometry data in FCS Express, is that you actually have access to each of the single cells that you've done in your analysis. So when the Chemometec software comes in, it determines where a cell is on this image. It also generates an individual cell cutout for each of these individual cells. And what we can do is in this, what we call a cell gallery, where we're looking at all the individual cells, we can also show which gates those cells belong to. So in this case, you can see that this first cell belongs to the red and the blue gate. That means that this is a non-viable or apoptotic cell, and in particular, since it's red, it is non-viable. So that means it's taken up propydian iodide, probably doesn't have very much VB48. Now, as we scroll down this list, you notice that we also have cells like this that fall into the apoptotic and non-viable category, but most of our cells are viable. Again, this is a negative control, and you can see that by scrolling through here we can find those cells. Now, again, these gates work directly on this data grid. So if we want to look at all non-viable cells in our assay, we can apply that gate there, and now you notice that everything is red because these are all the non-viable cells. And again, if we want to look at just the apoptotic cells, you notice that in this case they're all a lot smaller. Maybe this is a particular interesting thing in this assay. Any of the cells that we look at on the image, maybe if we want to zoom in here, it looks like we have some viable cells and an apoptotic cell in there as well. Again, we'll color this orange. These represent 0.4% of the population, but if we apply this gate to the data grid, we can get an idea of what's going on with these individual cells. Again, we see that many of these are viable, and that there's one in here that's apoptotic and falls in our non-viable or apoptotic category. And we had a question that says, are the images in columns 3 to 5 identical to the cells in the microscope image on the right? So are the images that fall in this data grid or this cell gallery same as the images on the right? They actually are. These images are derived directly from this picture plot, directly from the images taken on the microscope. All we are doing is going in and saying, where was the segmentation for this cell found? Anything that was found in what's called the segmentation mask, display that on the left in our data grid. So these are the actual images coming from this microscopic image. And that's what allows us to relate everything back and forth from single cells to dot plots to the actual image itself. So when you're in FCS Express, you have all of this power to work with these images. I think you could see how all of that works and why it's very important. You're not losing this spectacular imaging data that Chemometec is providing. You're now actually able to take everything you've done a step further by linking all of this back to the images. But FCS Express does have some more capabilities here. If we want to do a histogram analysis and just look at our early apoptotic versus healthy cells, we can actually overlay all 3 of our different time points for our negative control here. Again, if we change our data to the next data file, we can see how all of this changes between our negative controls. You can see there's more early apoptotic cells in this MeMo-treated sample. And again, as we scroll through our different samples, our histograms are going to update in real time, and all of our statistics will as well. Now, another great tool in FCS Express is we can create bar plots, we can create charts, we can create nice tables to display all of your analysis results. And as we update our samples, you can see here as we change between our samples, we can see how these bar plots update. Another important thing to note is that all of these bar plots are directly linked to the statistics in our gates or our analysis now. So as we adjust this non-viable cells gate, you notice that all of our non-viable cells have updated in the bar plot. So we can see how changing our gating is actually going to change between samples over time, and we can see how all that updates in real time. So if we really want to come in and make sure our negative gates are set in our negatives, we can very easily do that. So once you've done all of this, what you probably want to do is not just analyze, these 3 time points of data. What we want to do is analyze all the different data files in the data set that we've collected. As you saw Henrik present earlier, there were many different treatments. In this case, we pulled in 4 different treatments, the MIMO, the CPT, and the ETO. If we wanted to add any more treatments to analyze, we can easily do that by clicking this plus button on our data list, and we can just come in and select the ones we want to add. So if we wanted to add our TNF data set to our analysis, you see we added that to our data list, and when we skip ahead, we can actually look at this TNF analysis. Well, let's show you how we quickly and easily export all these results in FCS Express. We do this through what's called batch actions. And in these actions, we can choose different things like exporting the PowerPoint, exporting the PDF, exporting any statistics that we want to Excel, and we can export to multiple places or multiple pages. So in this case, in our one PDF export, we're actually exporting page 2. So we're doing that histogram overlay analysis. And in this PDF, we're only exporting page 3, which was our bar plot analysis. So what I'm going to do is show you how this batch process runs very quickly. All we do is load our samples into FCS Express. We click Run on the batch analysis. And what is going to happen is FCS Express is going to simultaneously export to PowerPoint, to Excel. It's going to export our 2 PDF documents, one for our histogram overlays, one for our bar plot analysis, and it's going to do that over the 5 different samples that we have in our data list. And again, this doesn't have to be just 5. You can load up as many samples as you want. You can see here that in our batch processing window, we're on iteration 4 of 5, which means we're on the ETO sample now, and this is actually going to change over to our TNF alpha sample, and it's going to complete the batch process. And what you can't see on my other screen that I'm going to bring over is that PowerPoint has actually opened up, as well as PDFs and Excel. So I'm going to bring all of that over as soon as it's done loading. And what this means is that we now have a PDF document. This has all of our bar plots. See 5 different samples, so we can quickly and easily scroll through to look at the changes between these samples. We also have, if I can bring this over, our PDF document for our histogram overlays and our PowerPoint document. I'm going to bring the PowerPoint over here. So our PowerPoint document has all of our PowerPoint analysis here, including all of the bar plots for each of the individual samples. And importantly, for a lot of people, again, we can export directly to Microsoft Excel. So if we want to pool all of this data and look at the different treatments at different time points to get particular information and statistics, we can quickly and easily get all that information there. So as you saw, the batch process is a very powerful tool. It's one of the tools in FCS Express that makes this analysis very quick and easy for you. These templates that we've created here, or this analysis that we've created, can also be stored as a template. So that means you actually have this blank analysis page. And whenever experiments you run on your Chemometec instrument, if you want to bring in some new samples the next day, if you ran this again, we just load them into our data list. You can notice here that when we do this, all of our plots are going to load with all of our gates, all of our overlays, all of our bar plots. Everything is automatically created, and then you can hit run on that batch process to have everything exported in a way that's quick and easy for you. Now, I think that's the basics of what we want to cover for data analysis in FCS Express. Of course, there's a lot more things that can be done, especially with Chemometec data. We do have a Chemometec webpage on the Novo software website where we have many different analysis templates. So if you were doing a Nexon 5 PI apoptosis assay, here's an example of what that would look like. We can also do things like cell cycle analysis, where we actually model the cell cycle data. We don't just put in markers and gates, we actually model the overlapping populations. But any of these layouts, again, can be found on the Novo software website. You can come in here, download these layouts, and just pop your Chemometec data directly into them, have everything you need to know about them automatically populated on the fly. So with that, I just wanted to give a quick summary of what we've talked about in FCS Express today. FCS Express is going to leverage the most powerful and proven tools of a flow cytometry analysis, something we've been doing for 15 years, with new features to improve that image cytometry analysis. And that means you gain access back to the images from your dot plots. You have the ability to quickly and easily create bar plots that directly relate back to the images and the gates. Any of your statistics are live updating as well. And as you saw, we can move from the population-based analysis of dot plots down to the single cell analysis at the click of a button. All these things are interactive. All of the visualization, plotting, data analysis, it's all in one package. That means you don't have to export things to PowerPoint, to Photoshop to get them ready for a presentation. We can do all that in FCS Express and then export it to PowerPoint for you. And again, we also have many resources for our customers, like tutorials, sample data, online forums. We have customer support, so you can get up and running with the software in no time at all. We also offer a free 30-day trial, so you can bring any of your ACS files that you've exported or you've created in your Chemometec software, bring them directly into FCS Express, and you can get this demonstration version just by going to the Novo software website and choosing to download a demo. This is even going to have all the cell cycle analysis in there for you as well. I also wanted to open up the floor for more questions in just a moment here. I also wanted to bring up our contact information for both Chemometec and for de Novo software. And Henrik, is there anything you'd like to add before we open up the floor for questions?
No, I'm looking forward to get some questions, and I'm happy to see that there's quite a few people here. So there is not much I can add to your presentation there.
Great. Well, thanks again for presenting today, and we're going to move on to some questions that have come in. Henrik, it looks like there's a few here for you that maybe you want to address.
Yeah, I think I've addressed most of them during the presentation. The VB48 are mainly for mammalian cells, but we are trying to see if it works well in other types of cells like yeast and bacteria and so on. So that was one of the questions that I found in the question range here. So I see that most of the questions now are more related to your presentation.
Great. So one question that we have on the line, is it possible to analyze .tiff files from the FlowCam? That's fluid imaging. So FCS Express does not do any sort of image segmentation. We only work with image analysis. That being said, the Chemometec instrument is a very great way of getting your data to us. If that doesn't work out for whatever reason, if you do have images from other locations or other microscopes, there are pathways such as Cell Profiler and ImageJ, which are both free segmentation tools for getting your TIFF files to FCS Express. Again, on our website, we have more information on this, and we would be happy to follow up with you about how to implement things or how to implement imaging data from other images as well. And we have a question here about VB48, specifically for working on plankton cells. Do you offer product samples Henrik, for things like this?
We do offer trials of trialing our instrumentation, so please go to our webpage, and there you'll find a page specific for requesting trials of our instrumentation, and in that way also our dyes, of course. So that might be able that we can find a solution for that, so that we can do a trial on the VB8 on plankton. However, one of the big issues with some planktons, at least, but all plant cells, is that there is this cell wall that tends to be a border for different dye processes. But you're very welcome to contact us either in the email address or directly go to the web page and then request a file, and I'll be happy to work on with this specific case.
Great, and it looks like there was another question or comment here that was regarding quadrants and the limits set for the quadrants. It's not totally clear what the question is, but I just want to let you know that in FCS Express you can change these quadrants however you want if you set up quadrants. I know that the quadrants in the FlexiSite software are also flexible as well, as you saw Henrik moving those around. In FCS Express you can move quadrants, you can move gates any way that you've like. All that is freeform and open to you as the user. And are there any other questions for either Chemometec or Novo software today before we end the webinar? All right, and if you have any questions after the fact, again, you can contact sales@chemometec.com with your questions. You can contact info@Novo software with your questions. Either of us would be happy to answer any questions you have and direct you to the correct people. We'll also be following up with everyone after the webinar today, so if you have questions you can contact probably Henrik and myself directly. So thanks again, Henrik, for putting on a great presentation about the apoptosis assay and the capabilities of the NC3000. We really appreciate it.
Well, thank you too, Sean. It was very nice seeing how everything works in FCS Express directly from our software, and that the two softwares combine our software with our instrumentation, and you combine it, a really strong tool.
Great. And again, thanks to everybody for coming out today. If you have any questions, just feel free to contact us, and have a great rest of the day. Take care and bye-bye.